So we're just going to jump right in. So we're going to talk about decarbonization as a design imperative, on par with other design imperatives, such as centering human wellness and equity. And we're going to examine our design process. We've been examining our design process and ask, how deep has the commitment to decarbonization seeped into our design DNA? So we're all familiar with some of these graphics and the recommendations from organizations like the Carbon Leadership Forum and Architecture 2030, 40%, 45% reductions in embodied carbon. Those are significant numbers. They're not easy to do. So how do we do that? What we found through some success and through some failures is that the first step is to set targets. Targets create design discipline for your teams, which helps them prioritize decisions and make some difficult decisions, because there will be difficult decisions. So set a decarbonization target and challenge your teams that creativity is not just an aesthetic challenge, it's also a problem-solving challenge. So challenge them to be creative and think about design for decarbonization in a big way. Next, please. So once you set your targets, then the next step, of course, is to target the hotspots. And of course, we all know concrete, steel, those are the hotspots, but also glass, insulation, and others. And don't overlook small decisions. It's not all about big numbers. It's about the small numbers that add up. Because remember, you're trying to hit a target. So don't overlook small decisions, because we do need to turn over every stone. We're going to hit these targets. Next. So let's look at what at first appeared to be a small decision. This is a plan of an entry canopy on a local high school. A little backstory. So in Integrus, we're signatories, like a lot of firms, to the 2030 challenge, and our in-house structural team are signatories to the SE 2050. And we've got some people on that team who are really leading the effort of decarbonization of our structure. So the designer on this project said, I want an open plan with free circulation, open space for gathering, which sounds beautiful, right? The engineer was appalled. He said, how can you create a span or a beam size that's twice what it needs to be? If you just put a column in there, you can reduce the carbon by half. Okay, so there was a little bit of back and forth and a compromise. The engineer proposed location 1, the compromise put the column in position number 2. So what are the implications of that? What was the outcome? Next slide. Oops. So this is what it looks like. You can't really see the column, but here it is. The point is, in terms of aesthetics and functionality, the column barely registers. But what does it mean in terms of column? It reduces the beam that supports that span by half. And so, that's equivalent to 29,000 pounds of coal burned. 29,000 pounds of coal for one column, 61 barrels of oil, or the carbon sequestered by 34 acres of US forest. So, we really love our engineers at Integrus. Let's look at some floor plans. So the plan above is sort of, what you would expect if you were going to set out to optimize a plan for structural efficiency and minimizing carbon, minimizing steel columns, minimizing carbon. Plan below is something that looks more like what we produce when we design a typical middle school in response to a very complex needs of the program. So we're not saying that we can never do this, and we always have to be constrained by the rigor of decarbonization. But when you have targets, then you're able to navigate some of these difficult decisions. Maybe we do get to do this on occasion, but we do something else, right? But the targets allow us some latitude for decision-making so that we can still make good decisions, but stick to our decarbonization targets. So targets are important. Next slide. Let's talk a little about brace frames. So your engineer says, well, I give you a brace frame that's 15 feet or 30 feet. You say, I'll take the 15-footer. Nope, no brainer, right? Well, the 30-foot brace frame has a 65% reduction in concrete. So maybe it isn't such a no-brainer. Again, targets help you navigate those difficult decisions. We don't want to say that decarbonization in design is prescriptive, but we have to find ways to be able to make these difficult decisions, which is what we're trying to do and trying to share with you today. Next, please. Another thing about brace frames is if you rotate them from the orthogonal, the building code requires that they be designed for a 30% increase in the load that they're resisting. Or if you locate columns at corners like that shared between two brace frames, they also pay that same 30% premium in loading. So, just how important is decarbonization? What are you willing to accept in order to achieve the lower carbon? I think you need to ask yourself, are you ready for the orthogonal apocalypse? Here's a common problem. We all love open corners. They're better for views, they're better for daylight, better for the feel of the space, and so on. But, they usually require additional steel at the corners. So, prescriptively, we don't want to say no more open corners, but you might say use them strategically. Use them for effect, but not in every case. So make decisions like this the exception, not the rule. Let's talk a little bit about brick. Brick is absolutely essential to, none of us are willing to give up on brick, but brick has some real challenges. One of them is that the steel code says that for brick above 30 feet, or brick needs to be supported at every floor above 30 feet. And when you do that, you pay an additional penalty in the embodied carbon burden of that steel that supports the brick. In this case, there was the cost of running that brick above 30 feet in 3 stories was 50,000 pounds of coal burned, or the equivalent of 50,000 pounds of coal, or the equivalent of 53 acres of US forests sequestering carbon. So, how do we navigate difficult decisions like this? I think, again, just to sort of hammer the point, it's the discipline of a decarbonization logic in your design that helps you navigate those decisions. So we've been looking at some specific sort of technical cases and suggesting that the logic of decarbonization changes our response to those problems. In fact, maybe the logic of decarbonization suggests a broader reconsideration of some long-held architectural values. And so I'm going to turn it over to Will, and he's going to share some thoughts on that subject.
Thanks, Pat. So I want to start to frame that question with 2 observations that'll seem completely unrelated. The first is that we recently passed the centennial of Mies van der Rohe's prophetic competition entry in the Friedrichstrasse Berlin skyscraper competition. The second is that I was on a construction site recently and I realized that all the space between the studs that I thought we were going to put insulation got filled with more studs, which is bad because it means the portions of the wall that are solid wood will have an R value of 9. It makes me feel better, though, to realize that curtain wall, high performance, low-E coated, thermally broken curtain wall or storefront typically only gets an R value of a dismal 3, which means that the highest tech building enclosure system that we commonly use is 1/3 as effective thermally as a log cabin. Surprisingly, though, despite the low thermal performance, the high solar heat gain, and the high embodied carbon of curtain wall, Mies's vision has remained pretty persistent for the last 100 years. We still dream of beautiful, ethereal glass shards. That hasn't really changed. One thing that has changed, unfortunately, is global annual carbon emissions from burning fossil fuel. In 1921, when Mies submitted that drawing, our emissions were below 5 billion tons a year, and now they're over 36. But it's been a fun 100 years. Everyone from SOM to OMA, from Saarinen to Sauna has embraced the aesthetic of glass. It's not just that we want to look at glass, we want to see the glass, we want to look through it, we want to look at it, we want to be around it. It's emblematic, it's iconic. So I thought it would be interesting to look at a couple of precedents that try to reposition the role of glass in a building's aesthetic. This is Grafton Architects with a university project in Ireland. Rather than trying to highlight the glazing, they're actually creating a form out of obscuring it, which also has daylight implications, but I think just purely from an aesthetic standpoint suggests one way forward. Marlon Blackwell has a couple of projects where they treat glass as a figure rather than the sort of modernist impulse of treating it as a field. So the glass's importance in the composition is amplified by using less rather than more. But what about daylight? Don't you need big expanses of glass for great daylight? One of the office spaces that I particularly like in Seattle is a great example of orienting glass based on what makes sense from the solar angles, and then using an amount that balances the light and then incorporates it into a composition rather than making it the sole feature of the facade. Now, maybe I've unfairly characterized the last 100 years as one big glass orgy. I want to be clear, there's a lot to learn from the Western canon. People like Caesar and Kahn doing a really interesting job engaging daylight without promoting a glass-forward aesthetic. And then if we broaden our view even wider, look around the world and across time, I think we see that cultures have long created architectures that meaningfully reflect the social and material conditions of their time and place, while also seriously addressing their climate. And I think that's ultimately what's interesting about Mies's drawing. He's engaging critically, he's engaging carefully, he's engaging beautifully with a very particular engineering, scientific, and cultural context. But 100 years later, our context has changed dramatically. Maybe our architecture should too. Thanks.